Hey guys, today's lesson is about mixed numbers and improper fractions. As you can see here, I got three different things written down here because these are kind of types of fractions that we're going to be working with. We have what we call proper fractions, improper fractions, and then we have what we call mixed number, which is a whole number and a fraction all in one number. Proper fractions are what you're used to seeing, all right? Things like 1/2. It's proper because the numerator, the 1, is going to be smaller than the denominator, the 2. So that's why it's called proper, because that's what fractions are supposed to be. So anything where the numerator is smaller, like 3/4 is called a proper fraction, and something like 5/7, those are just a couple. But anytime that the numerator is smaller than the denominator, that's the way fractions are supposed to be. Proper fractions. Improper fractions then are what's not supposed to happen. So improper fractions are when it's just the opposite. When we end up getting the numerator that is larger, all right? A fraction's not supposed to be that way, so we call it improper. Okay, so anytime that the numerator is bigger than the denominator, like 10/7 or like 5/4, though, again, those are just some examples of what improper fractions are. Now, mixed numbers, okay, is when you have a whole number and a proper fraction together. So something like 3 1/2 would be considered a mixed number because it's a mix. It's a mix between a whole number and a fraction. Okay, something like 4 5/12 is a mixed number, and then 7 2/3. So those are just some examples of types of fractions that we're going to be working with in this lesson. Okay, let's go ahead and do a couple things here. So example 1, write each mixed number as an improper fraction. So if we have mixed numbers, sometimes we're forced to change these things, whether it's because we want to compare fractions or maybe it's because we want to add, subtract, multiply, divide. There are times that we want to take something like 3 5/6 there and change it into an improper fraction. So that's what we're going to learn here. So I'm going to do part A. I'm going to let you try to do part B on your own. So if we're going to change this, we're going to start with the denominator here, the 6. And really we just want to work in a clockwise manner. So if I do this, I'm going to start and I'm going to go 6 times the 3, which is 18. And then I take that 18, and then I'm going to add on the numerator. So 18 plus the 5, that ends up giving me 23. That becomes my new numerator. So again, you're going to work in this clockwise manner. You do 6 times 3. And then remember, we're going to add on the numerator. So add on the 5, which is your 23. And this denominator here, the 6, that just comes along for the ride. That's always going to stay 6. So really what we're looking is you can bring the denominator over right away. We're looking for the new numerator. Okay, pause the video. You guys try part B on your own. Okay, hopefully you're back. Let's compare what you did with what I'm going to do. Okay, so again we start. What I can do is this. If I want to say this is going to equal, the one thing right away is this 8, the denominator. I know that the denominator is not going to change, so I bring that over right away. Then work in a clockwise manner. So we do times first. 8 times 4 is 32. And then I add on that 7. So the 32 plus the 7 gives me 39. And there is your improper fraction. Okay, next type of problem. It says write 21/6 as a mixed number in simplest form. So again, when I see that slash there, that's just the way it's writing this as a fraction, 21/6. So if I want to write this as a mixed number, so really we're just going backwards. I'm going to go back a page here. Okay, in this problem, what we were doing was we were taking these mixed numbers and we were making them improper fractions. What they're going to ask us to do now is to take these improper fractions and change them back to mixed numbers, just because there's things that we want to do this for. So 21/6. Well, one thing that we've talked about before is that this fraction bar means division. It means that we're going to divide. So that's exactly what we want to do. So I'm going to put in my long division box here. And remember, when we're dividing, okay, it's always the top number divided by the bottom number. So if I said this out loud, I would say 21/6. The number that you say first always goes inside the box, no matter what. It's not always the bigger one, like a lot of people think. It's always the top number. So the 21 goes inside. That means the 6 is going to go outside. Okay. Then when I go ahead and divide this, okay, I think, okay, 6 goes into 21 3 times. 3 times 6 is 18. I end up getting 3 left over. Okay, so here's how you write this. when I'm going to write my improper fraction, since 6 went into 21 3 times here, 3 is going to be the whole number. Okay? The remainder here is what ends up becoming your numerator. Okay? Your numerator. And so that's here. And then, just as always, this denominator was a 6. That's always going to stay a 6. So you end up getting 3 and 3 6. Now, one thing it does say here is that it wants it in simplest form. Well, that's something it shouldn't even have to state. When we're working with fractions, we always want to reduce it. We always want to put it in simplest form. So what we're talking about here is the fraction part. Okay, the whole number is not going to change. That's going to stay 3. Okay, but we know that 3 6, if I divide that by 3 on top and bottom, that ends up becoming 1/2. So 3 and 3 6, reduce the fraction part, ends up becoming 3 1/2. Okay, I'm going to do one more for you. I'm going to do part A, and then I'm going to let you go ahead and do part B. So A, same question here. Okay, we're going to write these improper fractions as mixed numbers in simplest form. Okay, I know the fraction bar means division. Since I would say that is 15 over 3, the first number you say, the 15, always goes inside, the 3 is outside. Okay, when I do this, I end up getting that 3 goes into 15 exactly 5 times. 5 times 3 is 15. Look at this, I end up getting nothing left over. So what ends up happening is, since 15 divided by 3 is 5, we end up just getting a whole number, a 5. Okay, part B is on you, so go ahead, pause the video. I'd like you to try it on your own. Okay, hopefully we're back. What we should have been trying here is doing division. The first number, the 50 that you would say, goes inside the box. The 7 goes outside. 7 goes into 57 times. That's 49. We get 1 left over when we subtract this. Now, if we kept dividing, we could end up getting a decimal out here, but that's not what we're doing today. We're not trying to change things into decimals. We're trying to keep them as fractions. In this case, mixed numbers. So what you end up doing is this. Okay, this 7 here ends up becoming the whole number. Okay, the remainder ends up being the new numerator. The denominator doesn't ever change. That's going to stay being a 7. And there's our final answer. Okay, last problem for today. Compare the mixed, or it's an improper fraction. Compare 17 over 6 and the mixed number 2 and 1/4. So we got 2 different types of fractions here. Well, it's kind of like a lesson on comparing fractions. We don't want to compare things that don't have the same denominator. Well, we don't want to compare things that don't look alike either. So I don't want an improper fraction and a mixed number. So either I've got to make them both mixed numbers, or I make them both improper fractions. What I'm going to choose is I want them both to be improper fractions. So I'm going to leave that one as 7 over 6, and then this 2 and 1/4 I'm going to change. So I'm going to change that by doing 4 times 2 is 8. 8 plus the 1 gives me 9 as my new numerator, fourths. So 2 and 1/4 becomes 9/4. Now, it's just like any lesson on comparing fractions, where I don't want to compare anything when their denominators aren't the same. So I'm going to make these equivalent fractions that have the same denominator. So I know that 6 and 4 can both become 12, so I'm going to do that. Okay, 6 becomes 12 by multiplying by 2. So then I do 17 times 2, which gives me 34. And you might have to do that off to the side. That's okay. 17 times 2, 7 times 2 is 14, 2 times 1 is 2, plus 1 is 3. So that's how I got that 34. Down here, 4 times 3 is what gives me 12. So I have to do 9 times 3 is 27. And now comparing these two things, the numerators, 34 is larger than 27, so I know that this is the bigger one. Okay, in its original form was the 17 over 6, so I know when I'm comparing 17 over 6 compared to 2 and 1/4, that 17 over 6 is the greater one, so I go ahead and throw in my greater than symbol. Okay, that's our lesson for today on improper fractions and mixed numbers.